All right, everyone. Selecting the correct hose for an industrial gas or cryogenic application is very important. It's important that you select the right type of hose. I had the fortune of for about 7 years, I worked specifically with a hose manufacturer in the United States. And so I got a lot of exposure to how all the different hoses are used across the states. What I saw was it seems like 90% of the hoses that you see out there have an inner core of PTFE or Teflon. Can everybody hear me okay? Hans, do you hear me all right? You can
Yes,
just give me a thumbs up.
Yes,
yeah.
we can hear you.
Okay, good. So today what we're going to talk about is PTFE hose, ETFE, all metal corrugated type hoses, which are typically 316 stainless. We're going to go a little bit into beverage, CO2 transfer. I'll talk a little bit about tube trailer hoses and then bulk delivery hose. If any of you out there do not have our new catalog, I would highly recommend get it. And when you get the new catalog, you're going to discover that these classes that we put on, I'll be giving you the page numbers of the products that I'm talking about and directing you to specific information on different hoses. If you get the catalog, it'll take you right to the spec sheet you're looking for on a particular type of hose. So with that said, PTFE Teflon is the most common hose out there. You hear the term post-centered from time to time. What that is referring to is a standard hose, which looks like this, has a Teflon inner core. Next, you see an armor braid, a stainless steel braid is put on top of that. This works a lot like the old Chinese finger twist that you put your finger in it, and as you pull on it, it tightens. That's what this braid does right here. With one layer of braid, stainless steel braid on this hose, it takes it to 3,000 PSI. Without this braid, this is only capable of holding about 100 PSI. So this braid right here is very important. If I take this braid and put 2 layers down, okay, it looks something like this, not much bigger, but this particular hose here, you notice it's milkier. It's much milkier. That's a post-centered hose. And all that means, post-centered, is they take the Teflon, pull it out of the oven after it's been cooked. For the standard hose that everyone uses, it's good to go. On the post-centered, they put it back in the oven for a controlled period of time at a controlled temperature. And when they pull it out of the oven, it actually bonds the molecular structure of the Teflon to where it's very tight. And what that does for us, it reduces permeation by 75%. So a post-centered hose, in this particular case, this has 2 layers of stainless on it. I'll talk about that in a second. The post-centered hose greatly reduces permeation. And for anyone that doesn't know what permeation is when you put gas into, I'll pick something like a balloon. If you were to put helium in a balloon and tie it off, it would float up to the ceiling. If you let that balloon sit there and came back the next day, you would notice that it isn't as high as it was the day before. And each day that goes on, it will drop down a little bit more. The reason is the helium inside the balloon, very small molecular weight, very small molecule, is escaping, permeating out of the balloon. And the longer that balloon is in the air, it'll just keep going down until it hits the ground. Well, then it doesn't have enough helium to keep it lifted. So permeation is the ability for a gas in this tube to escape. And what you need to know on hoses, any PTFE hose out there will permeate. So there will be some permeation. That's a real concern when you're looking at gases like hydrogen. You don't want gas permeating into an enclosed area. So what we did in this particular case was I designed this hose for one of the major manufacturers, and they use it now in all their plants, and that's air gas. This hose has a post-centered inner core, and instead of one layer of stainless steel braid, I put two on here. That takes it from 3,000 to 3,600. So for one layer is 3,000, two layers, 3,600. If I put 4 layers, like this hose has, that takes me up to 4,000. So I can throw on 2 more to make 6 layers total. That'll get me to 6,000 PSI. But basically the way you get strength on hoses is through this braiding right here and the amount of layers we put down. This is something you should be aware of as well. This is called corrugated metal. It's basically 316L, and they take it, it's a sheath that they take and they run it through a series of drive rolls which curve it over, then they TIG weld the top. Yes. And then run it into a machine that corrugates it. And basically by a push-pull method, it takes the metal and stretches it into this shape. Thanks, man. There's 2 ways to stretch it, mechanically and hydraulically. Mechanically, you're literally stretching that metal. Hydraulically, you're pushing the metal, which is much softer. The reason I bring that up is when you mechanically form this corrugation, the very crown of the corrugation is susceptible to cracking when you're filling, and the flow rate goes beyond 150 feet per minute. So when you're filling with hoses like this, a liquid transfill hose, you never want to exceed a certain flow rate for the hose you have. And by the way, every hose out there has stamped into it or engraved on it. It has the date it was manufactured, the manufacturer's name, and the MAWP, the average working pressure, maximum average working pressure. That's a key piece of information that you need to get when you're trying to qualify a hose for a customer. So next slide, please.
Hey, Patrick, I just want to jump in. I think there's one person that isn't muted and keeps popping up. If you wouldn't mind just double checking that you've muted yourself or mute your cell phone if you're using your cell phone. Thanks.
Okay. All right. When selecting a hose, it's important that that's my security system. When selecting a hose, it's important that you ask 6 questions if you want to get the correct hose. First off, what's the application? Is it gas or is it cryogenic? What is the pressure you need the hose for? Knowing the maximum pressure is key to getting the right hose. Let's face it, you don't want to, you want to find out, are they dealing with, do they want the hose to be 3,000 maximum pressure? Most fill plants today will fill up to 2,200 at 70 degrees. 3,000 gives you some cushion. If not, we have hoses that go all the way up from 6,000 to 10,000 PSI. Okay, next question is what pressure, what's the maximum pressure the hose will see? After that, ask, does somebody have, somebody must have their microphone on out there. If you wouldn't mind putting it on mute. You can ask the customer the flow rate. That's important for the size of the hose. I'll be honest with you, over the years of doing this, most customers are not familiar with what their flow rate is. And so don't be surprised if they don't know their flow rate. Pressure is more important, making certain that you have the maximum working pressure. The other thing to question you want to ask is, what is the length of the hose that you want? Keep in mind that these hoses are built in 12-inch increments. So if you're ordering 6 foot, 7 foot, 8 foot, you're more likely to find those hoses in stock compared to a set length, like say 104 inches. That's going to be a special made hose. Next question you would ask, what are the end fittings going to be? Most common end fitting is 1/4 inch female NPT. From there, you could adapt any type of fitting over. However, 1/4 inch restricts you on your flow. So you want to make sure that you select the right hose by asking, is it going to be used? What application is it going to be used in? And is it going to be gas or cryogenic? Armor on the hose is basically this section down here. The armor on a hose protects it from dust and debris, but more than anything else, the number one reason for having armor on a hose is so I cannot twist it further than its bend radius. And if you don't know what bend radius is, if you were to take a hose and bend it to the point where it stops bending, you would measure across this point right here to get the bend radius. Okay, on this hose, it wants to stop right there. Now you might notice on this particular hose, I see it has a kink in it right here. If you walk through you walk through a fill plant and look at all the hoses hanging off the rack, you'll see some with a kink just like this. That's where they've been pulled on or they've been crimped. And let me tell you, that spot right there is where this hose is going to break when I put pressure on it. It may not happen right away, but it will happen eventually, and it'll happen in that spot. Once you've bent it beyond its bend radius, you've compromised the hose. Okay, next slide. The last thing you would ask the question you would ask the customer, do they need the hose oxygen clean? So those 6 questions, if you ask those to a customer, you should be able to get them the exact hose they need. What is the application? Is it gas or cryogenic? What's the maximum working pressure? Flow rate, I don't think you're going to get it, but try it. Length, try to get the lengths in 12-inch increments, 6 foot, 8 foot, 10 foot. That's how we stock them on the shelves. End fittings, whether you need FJIC or you want 1/4 inch, tell us. We could pretty much make any configuration you need. Armor, it protects the hose. I recommend armor to everyone because the hose will last longer, and as I said before, you won't be able to crimp it. And then last but not least, you want the hose clean, capped, and bagged for oxygen use. So those are the questions. All right, Marie. Now, I'm going to go through this pretty quick. Permeation, these are some of the common hose terms you hear out in the field. Permeation, as I said earlier, would be compared to a balloon that has helium in it. And the helium will eventually work its way out. That's called effusion. Diffusion would be the opposite of that. Gases working their way in. Maximum average working pressure is a question you should ask every customer. What's the maximum the hose is going to see? That will help you determine what's the best hose for its application. Diffusion and effusion has a lot to do with the size of the molecule. The 2 smallest molecules that we deal with on a daily basis are hydrogen and helium. Those are the 2 I'm most concerned about when in regards to permeation. Burst pressure. Every hose has a burst pressure. Typically, that burst pressure is 4 times the MAWP. So if a hose is set up for 3,000 maximum working pressure, the burst pressure is going to be 12,000. And we basically in our book, you can find this information. It's throughout our booklet. On the hose section, it'll tell you what the different bend radiuses are and what the maximum working pressure is. Post-centered, I explained earlier, it's a process that's done to Teflon. It's a second cooking of the Teflon, if you will. It basically pulls together the molecular structure of the Teflon and reduces permeation. Molecular size, you hear that term, especially with hydrogen and helium. Nitrogen, CO2, a lot larger molecule, so less permeation. CGA, everyone here knows what that means. Adiabatic compression, real quick, that's a phenomena that exists with oxygen and nitrous oxide. And basically, I'll say this, adiabatic compression, if you can imagine in a fill plant, a rack of medical E oxygen. They're all ready to fill. The operator's got all the valves on. Everything's ready. The valves are open on the cylinders. He hasn't hit the master valve yet. But if he misses one valve on that rack and leaves it shut and then opens the master valve, you get a rush of gas coming down to each cylinder. When it hits the back end of the closed cylinder, that's where adiabatic compression does its work, and it builds up heat quickly. It can build up to 2,000 degrees in heat in about 3 seconds. So it's very fast. And then it explodes. Reason it explodes, typically in oxygen situations, is because in a oxygen hose, which would be very much like the one I showed you earlier, this one here, the Teflon melts at 450 degrees. So imagine there's oxygen going through here. The adiabatic compression hits the back end of the valve, it's closed, and the heat starts building up in this area. This is where you typically see adiabatic compression taking place. It will literally melt that hose and it'll explode. And it's a pretty loud experience. You'll hear about it from time to time. That would happen about 5 or 6 times a year across the country. Swivel fittings, I highly recommend swivel fittings, especially on hoses where you're going to need to take it off and on. You need to have one end of the hose. They don't both have to have it, but one end needs to have a swivel fitting if you want to be able to put it on without twisting it too hard. Adapters, I mean, we've got an adapter for just about every application you could imagine. I would say this about adapters: use as few of them as you need to. Basically, they're another point where you might have a potential leak. Oxygen and oil, I shouldn't have to tell anyone on this meeting about oxygen and oil, but just in case you don't know about it, they do not mix. You don't want oxygen and oil near each other. If you think that a hose has oil on it, don't use it. Take it out of rotation. You want to keep oil away from anything with oxygen. Hydrogen, as I mentioned earlier, permeation where gases escape through the hose. With hydrogen, I always ask the customer, are you using it indoors or outdoors? And if it's indoors, I will recommend that they go with an all metal hose. Now, this again is an all metal hose. The thing that's really nice about all metal, as it sounds, there's no permeation, zero permeation on an all metal hose. So when we go through the hoses, which we're going to do in a minute, I'll show you which ones are all metal. Those are great hoses for high purity gases, gases where you're concerned about the integrity of the quality or quality of the gas. Use an all metal hose. Teflon type hoses are used more commonly in fill plants. 6 packs, 12 packs, Teflon hoses. Rigid hoses, I don't recommend at all. Rigid hose had a time when they were the hose, and they really, through experience of using rigid hoses, people learned that they're going to crack. And I tell people you're always one bend away from it cracking, and they will eventually crack on you. Rigid hoses are the reason the flexible hose industry even started. They needed to find a better way to do it. And they came up with the Teflon type and the corrugated type steel as the inner core, and then use the stainless steel as the braiding for the strength. Next slide. These are the hoses in the book. I've got the page numbers on here. As I said, get your hands on one of our catalogs because in the classes we will refer to the book. But these are your two standard hoses that if you had a customer that needed a good quality hose for any application, inert gases, anything in the shop, we can make these hoses up to 30 feet in distance and put basically any kind of fittings you need on the end. If you're unfamiliar with fittings, use 1/4-inch NPT. It is the most popular fitting, and you can adapt almost anything over to it. FPT type hose in our catalog is basically the same as the FP, but it's the post-centered hose. So permeation drops 75%. I have 2 layers of braid, so it goes up to 3,600. So this is a more robust hose than the FP. It has a lower permeation rate and a higher MAWP. Good hose. For about, I'll say 23% more in cost, it's well worth it. Next slide. We have a hose. If you have anybody doing any gas work and you want a very high quality hose, we just came out with this about 1.5 years ago, FPB. It's got a conductive liner in it. It's designed specifically for acetylene. Will it work with propane? Yes. This is well above what you would use in a propane application, but if you have anybody using high purity acetylene or a critical application, this is a great hose and it's economically priced. It does have a PTFE inner core that is conductive. We can put basically any kind of brass fittings on this hose, but up until about 1 year ago, this type of hose would have cost in the neighborhood of around $65. These sell for about 43, right in that neighborhood. So they're quite a bit cheaper than what we had previously. Next slide. This is an all stainless hose. This is a 1/4-inch hose designed for high purity gases. When you use this hose, it'll, all the gas we'll see is stainless, 316. It's all steel. So when as I said earlier, with the all steel, stainless steel inner core, there is 0 permeation. So you don't have to worry about any leakage, any gases effusing or diffusing. The working pressure on this hose is 3,850 PSI. This is probably one of my favorite hoses in the catalog. Great for high purity applications. We can make this any length you need it with just about any fitting you need on it. We do have a program, I'll talk about it at the end of our session, that can figure out a part number for the exact type of hose you need. Next slide, please. This is FPZ. This is a TEP-ZEL type hose. The inner core is ETFE, so that means it's a plastic formula. It's basically designed to lower permeation. It brings the permeation down about 60% compared to the FP with an economical price. This hose is set up, and you need to let us know which one you want, but you can purchase it set up for 3,600 or 5,000 PSI application. Very low effusion. TEP-ZEL is the name of it. Typically, we can put JIC end fittings on this or NPT. You can armor, again, I recommend armor on all of these hoses. Next slide. This is FPS 45, very much like the hose I showed you earlier, all metal, all stainless. This one will get you up to 6,000 PSI. Great for high purity applications, a very robust hose. Keep in mind, if you're putting it in an application where you're going to be tightening down both ends of the hose, make sure you put a swivel on one end. Next slide. FPC, the picture fell off of this, I apologize, but we do have hose made out of Manel. So it's the inner core is 100% Manel construction. So if you're working with chlorine or corrosive gases, we do have a hose that'll fit that application. We can custom make it any length that you want. Great. There are some companies out there that use Manel for oxygen, and Praxair is one of them. It's become very popular. This is a great hose. I can see right now I made a mistake on the slide. It says PTFE inner core. That's not accurate. I'll take that off. It's a Manel inner core. And so keep in mind that we do have Manel hoses available. Next slide. CO2 hoses, this is where I wished everyone had a catalog in front of them. When you get the catalogs, you can look through it and you'll find that we've kind of fortified our CO2 line. We have a lot of hoses to choose from. The typical hose TPL is designed for gas or liquid applications. It's 3,000 PSI MAWP. It's a great hose for beverage applications in a restaurant, bar, wherever you're setting up a gas system or a welding station. These hoses will work great for CO2 transfer. Good hose in 1/4 inch. Next slide, please. This is an SF32 high pressure tube transfer hose. These are designed for tube trailer transfer. One thing I should tell you is tube trailer transfer is probably one of the highest flow rates you're ever going to see in regards to what we do on a daily basis. So you have to be very careful that the hose you use on a tube trailer, if it's all metal, an all metal hose, it has to be designed for a tube trailer transfer. Otherwise, what'll happen is, as you crank up the flow rate, the hose will start to resonate. And what's happening in the hose, it's shaking. Once you get above 150 feet per minute on flow rate, this corrugation right here will start shaking. Any of you out there, have you ever heard a liquid transfer hose humming while you're filling a product? Well, that's the beginning of this resonant frequency that I'm talking about. And on the hoses that are mechanically formed, this is their weak spot right here on the very top of the crown, the corrugation. They'll crack. And so let me tell you, in the tube trailer business, I saw a lot of these hoses that were ruined because They ran them off the back of a tube trailer at about 5,500 standard cubic feet per hour. That's enough to ruin this hose. What we do to correct that problem is inside this hose, we put a Teflon liner. So you have a smooth bore internally. That allows the gas to go through. What's happening to the corrugated gas or the corrugated hose is the gas gets inside the corrugations and starts spinning. And that's what creates that resonant frequency, the shaking. And it shakes enough to where it cracks all along the top of the hose. With an armor casing on it, you can't see anything, but you can hear that the hose is leaking. So keep that in mind. Metal hoses are great, but only up to a certain flow rate. This hose with a Teflon liner in it can handle up to 4,000 MAWP. It's a great hose. If you have any applications out there where you're going up that high in pressure, I highly recommend you get the tube trailer transfer hose with the PTFE liner. It has a 3/16 shell, just like this, but it has the Teflon inside. Okay, next slide. Liquid transfer, pretty easy. These hoses don't have to hold a lot of pressure. Typically, they'll go up to about 1,000 PSI MAWP. These are set up in our catalog where you can purchase the hose with a gas diffuser. They're 1/2-inch ID liquid transfer lines. We have like the top 3 gas diffusers we offer with this particular hose, and you can find it on the shelf in 4, 6, 8, and 12-foot lengths. Very popular hose. We keep these in stock in both Nashville and Livermore, California. Next slide. Cryogenic bulk hose. In the catalog on section 19B, there's probably 20 pages that will tell you every bulk fitting that you might come across, all the way from 1 inch to 1.5, 2 inch, 2.5. We offer them with 18-inch armor cups or full-length armor. Custom lengths are available. We can get them oxygen cleaned if that's what you want, but bulk hoses in our catalog, we cover them in great detail. So again, another reason to get that catalog. Next slide. This is a graph, and I'll make sure we get this to the key person. This is basically all the different hoses we have, and it's a quick way to identify for a particular pressure which hose you want to use. I can make this available. After we get done here, I'll find out who I should send this to, and we'll make this form available to all of you. Next slide, please. Same thing, goes over the bend radius, size of the hose, and the working pressures. And then the last piece of information basically tells you where you can find the hose in our catalog. Next slide, please. And that's it.